Hi everyone, we'll look at Spark SQL, which is doing queries using Spark without writing Spark code in Scala, Java, or Python. How do we do that? For Hadoop, you may recall that instead of writing low-level MapReduce programs, we write out the queries in HiveQL instead, which is very similar to SQL. Programs written in HiveQL are automatically converted into MapReduce program. However, such programs may take time to run since Hadoop MapReduce programs are disk-based. To take advantage of Hive and to speed up computation, Spark offers Spark SQL, which is like Hive but ported to Spark. In terms of architecture, Spark SQL replaces part of the Hive architecture, specifically the MapReduce programming model, shown at the bottom of the screen, and also the query planning, optimizer, and execution components. This screen shows the architecture in Spark SQL. The components in blue are what Spark SQL has introduced or replaced. Note that the very bottom layer, HDFS, is still intact, since this is where data is stored. And neither Spark or Spark SQL comes with a storage system, so they need to rely on distributed storage like HDFS. For small queries, such as doing simple scans through a large text dataset to search for a particular word, they can finish very quickly once the data is cached in memory, shown as the green bar here. If we do not keep the data in memory, then the speed of Spark SQL is quite similar to Hive. For more complex queries, Spark is also faster, though the speed up is not as dramatic. In this example, it is a few times faster. There are a number of components in the Spark ecosystem besides Spark SQL. Spark Streaming is another popular component designed to handle streaming data, as in clickstream analysis and real-time event detection, like spam filtering. The main idea behind Spark Streaming is that it extends Spark to first divide the streaming data into small batches, create RDDs for these batches, keep them in memory, and then run the Spark program pipeline on these in-memory RDDs. Conceptually, this is a very small modification of a standard Spark program that runs on the full data. This is great because we can easily intermix batch and ad hoc queries. With a large number of machines, Spark Streaming can process streaming data at high speed, up to tens of millions of records per second, with low latency. Another increasingly popular Spark component is the machine learning library, MLlib for short. It now has a good collection of some of the most popular machine learning algorithms. I encourage you to check them out. Spark can also process graph data via its GraphX component. It has some limited algorithm at this point. However, there will be more as time passes. When using Spark, the ideal case is that you keep all the data that you want to work with in memory. However, sometimes you may not have enough memory. If that happens, Spark gracefully degrades to spill the data to disk. Of course, this means slower speed, but the program will still run. Spark is now version 2 and is still relatively new. One thing to note is that version 2 has introduced breaking API changes, meaning this is not backward compatible with Spark version 1 programs. In this video, we look at some of the popular Spark components, such as Spark SQL, Spark Streaming, and GraphX.